Welcome students, welcome to the fourth lecture of the chapter Chemical Reaction and Equations. The topic of today's discussion is displacement reaction and the double displacement reaction. Till now we have covered the combination reaction and decomposition reaction. So after studying those two in detail, we'll be today dealing with displacement reaction and double displacement reaction. So about this displacement reaction, we can generalize this displacement reaction in this form. This AB is a compound. When it reacts with C, it is forming A plus BC. So you can see what is happening over here, that AB compound, C is forming new bond with B and A is left alone and BC is the new compound formed. Okay, so there is the displacement of the elements between the two reactants. Now we can make up the definition for this, that displacement reaction are those reactions in which a more reactive or reactive element displaces a less active element from its compound. Those are known as displacement reactions. Now you must have studied this in previous classes about a activity series. In this figure also tried to show the activity series. This is the decreasing order of activity series. The elements on the top like potassium, sodium, calcium, magnesium are the most reactive, and the elements which are lying down below here are the least reactive elements. Okay, these elements in this definition can be either a metal or a non-metal. So we have a series over here showing the reactivity of metals. In reactivity series, any metal can displace the metal lying below it from its salt solution. Let us see with an example of again a displacement reaction in which we have taken a copper sulfate solution which is originally blue in color, and we have kept a iron nail in it. We'll leave this solution for some time, and after that what we will observe that the color of the solution has been changed from blue to green, and there is some brownish deposition over this iron nail. We can make out the reaction in this form, that iron when reacts with copper sulfate, copper is being formed and the copper sulfate is being replaced by this new solution, the ferrous sulfate, which is now green in color. Earlier the copper sulfate solution was blue in color. Okay, so this is an example of single displacement reaction, or better we call it a displacement reaction. The iron nail is going to react with copper sulfate and there is the formation of ferrous sulfate and copper. Let's move to the activity series. Now in this activity series, as we have seen the reaction between copper sulfate and iron, there was the formation of copper plus FeSO4. Now with the help of activity chart, we'll see what just happened in our reaction. Let us just first see what is the position of iron. Okay, this is the position of iron. Let me mark it as 1. And what is the position of copper? Now it is lying below over here the copper. Let me mark it as 2. So as we have read in the definition only, the above lying metals, these are more active, so these displaces the less active metal from its solution. So this has happened over here. The less active metal solution, that is copper sulfate, when it was kept with iron nail, which was lying on higher position in the activity series, it will now displace the copper from its solution and form a new solution of SvSO4, and the deposition, brown deposition of copper will be there on iron nail. So this was the example of displacement reaction. We have a picture over here simply just to elaborate more the example just we have studied. Miss Copper and Mr. Sulfate. The copper sulfate solution we just studied, and Miss Iron with the iron nail we kept in the copper sulfate solution. Then what will happen? The new bond between Miss Iron and Mr. Sulfate is going to form, and Miss Copper will be left in the solution. New bond between the Mr. Sulfate and Miss Iron will be formed. Okay. Some more examples of this we have in our text is zinc and copper sulfate. Now just try to find out the positions again. Zinc lying above, and again copper is lying down in the activity series, and we know that the metal lying above in the activity series can displace the metals lying down in the activity series from their solution. So this is the formation of zinc plus copper sulfate as zinc sulfate and copper. Again, if I look at this example of lead, okay, lead, where is lead? Okay, this is the position of lead. Now this lead is when reacting with again copper chloride, so higher lying metal will displace the lower lying metal from its salt, and there will be the formation of new compound, that is lead chloride, and copper solid will deposit in the solution. This was all about the displacement reaction. Further we will be studying about double displacement reaction. So in double displacement reaction, if I just tell you with this figure, with the help of this figure, AD plus BC is going to give AC and BD. You can easily find over here that this D and C are exchanged, they have exchanged their places, and now new compounds are AC and BD. Done. So coming over the definition of this double displacement reaction tells that a reaction in which there is exchange of ions between the reactants, they are called as double displacement reaction. There is the exchange of ions between these ionic compounds. Let us see an example of this double displacement reaction. The example we have taken is again in our text. So sodium sulfate when reacts with barium chloride, the products formed are barium sulfate and sodium chloride. The solution of sodium sulfate is treated with the solution of barium chloride, and the white precipitates of barium sulfate are going to form in the test tube, and NaCl will also be there as a product in the test tube. Now we can see that what would have happened in this reaction. This sulfate ion have exchanged its place with barium, and same way the chlorine ion has exchanged its place with sodium. Earlier this chlorine ion was with barium, now it has formed a new compound with sodium. Likewise, the sulfate ion earlier was forming a compound with sodium, but in products it has formed a compound with barium. So that is the reason we can say that there is exchange of ions between the reactants, and this is the example of double displacement reactions. At last I would just like to summarize this, what we have studied so far. This is the figure showing the combination reaction. Next is the figure illustrating the decomposition reaction. Third is the displacement reaction. And finally, at last, we have the double displacement reaction. This was all about today's topic. Thank you and keep studying.